Yeah, it's the new iPhone 6. It's pretty cool.
Is this still, what kind of megapixels is this?
I have no idea, actually.
The big one or the regular size one?
I think it's the regular size.
Is it the 6 Plus or the 6?
It's the 6.
The 6? Okay. It's cool though, huh? Yeah, you might be the first person I talked to that has one of those.
Yeah, I really like it.
All right, let's see. What do we have here?
I wanted to see if I did 1 and 2 correctly, but I don't know.
Okay. Use your calculator to approximate all real zeros. So I'm presuming that when you plug that into your calculator, it only crossed the x-axis one time?
I believe so. Let me double check on that one.
Well, I can pull it up on Wolfram Alpha, all of these,
okay,
if you like. And we
that
can
works.
have a look at them. I don't know if we need to actually see them, but it's worth doing at least once, I think.
Mm-hmm. Yeah, it only crossed the x-axis once.
Okay, which would mean you would only have one real zero.
Correct. Yeah, and I got 2, 0.
Yeah, I'm not sure there's any other reason for us to look at it
Okay.
other than, yeah, because that's something you need to be able to do on your calculator, so you know how to do the trace and figure out the zeros.
Yeah.
Yeah, it looks like it only crosses at one time here. And it appears to cross it exactly at 2, and the beauty of Wolfram Alpha is they give you the root 2.
Right.
So this one you found 3 zeros.
Mm-hmm.
Minus 1, half, and 3.
Yeah.
Okay. You confident of that answer?
I'm double checking it right now, and
because I can plug that in. If you need me to check any of these, oh, okay. So you've only done the first 2. So go ahead and do number 3.
Yeah, they look right. Number 3?
Yeah, do number 3 on your calculator, and I'll be doing it on Wolfram Alpha, but I won't put the answer up until you get one on your calculator.
Sounds good. -6 x to 6.
And that way we'll make sure you're doing it on your calculator correctly.
Sounds good.
I bet you, I've never really looked, but I'll bet you there's a way for me to put an image of your calculator face on my screen and have a virtual calculator on my page.
Possibly.
You have the TI-84?
Yeah.
The TI-84 and the TI-Inspire are the ones I deal with all the time. I should look around. I'll bet I can do that. Although Wolfram Alpha is so powerful that I almost hate to use anything that isn't as good.
Sorry, it's taking me a little bit. I plugged it in wrong.
What's that?
I plugged in the equation wrong at first.
Okay, go ahead and get it right. In other words, it looks like this is almost the only value that tonight's session is going to give you, is to make sure you're using your calculator right.
Yeah.
The other beauty of Wolfram Alpha is that it shows you what you put in.
Mm-hmm. For one of them, I got -2, 0.
Okay.
And then let's do another one here. And then another one, I got -0.4, 0. that look right so far?
I get a negative. Okay, whenever you're finding numbers that aren't integers, in all likelihood, it's not a nice round decimal like 0.4. If you look at my page, you can see the four roots, negative 2, 1, and then probably that looks like 0.4 to you.
Okay, so 0.4 and then 1.
Well, it's not 0.4. It's 1 over root 6. And what it says to round it to the nearest hundredth. So go ahead and round that number. Does your calculator give it to you with a lot of places?
The only thing I've ever used is just decimals.
Right. How many decimals does it give you for that 0?
For that 0.
Or for that matter, for that 0 right there, because that'll be just the negative of it.
Let me redo it. Hold on.
0.4 what? In other words, here, let me divide 1 by square root of 6.
I got 0.4, like 0.408248.
Okay, so what is that rounded to the nearest hundredth? Which digit is the nearest hundredth? You got 0.408, right?
Mm-hmm.
This is the tenths. This is the hundredths. That's the thousandths. So if you round this to the nearest hundredths, what is it?
That hundredths, 0.40.
No. This causes you to round it up. 0.41. In other words, you have to look at the next digit after the hundredths digit to figure out how to round that up.
Okay.
So your answer is 0.41. And
0.4 over 1?
No, 0.41. In other words, it wants these zeros to the nearest hundredth. Right there. In other words, it doesn't want, the answer is 1 over square root of 6. Even though that's the precise answer, it wants you to turn that into a decimal and round it off to the nearest hundredth. And 0.408 rounds off to 0.41.
Okay.
And we have a positive here, and this is a negative. And then, of course, we have 1 and 2 are the other two solutions. Or, excuse me, 1 and negative 2.
So what's the third one?
Okay, so here's the four roots right here. Negative 2, 1, negative 1 over root 6 would be negative 0.41, and then a positive 1 over root 6, which would be 0.41.
Okay. Alrighty. So I get how to do those now. We should move on to like 7 through 12 and see how far we get.
All right, you're getting into the good stuff.
Yeah.
The hard stuff. Remember back when you thought the quadratic formula was hard?
Yeah.
Well,
indeed.
If only we had a cubic formula.
Yeah.
We don't have one. So we have to solve cubics the hard way, I guess. Is this a non-calculator problem?
It doesn't say so, but...
Yes, it does, actually. It says for questions 1 through 6, use your calculator. For questions 7 through 12, find all real and imaginary zeros. It doesn't say whether to use the calculator or not, but...
We should try one without a calculator and then another one with a calculator.
Okay. So when I say the words rational factor theorem, you've heard those?
I don't know.
Zero remainder?
Oh, yeah.
Okay. So if we have a cubic function, for that matter, a quadratic even, there is a theorem that says that if there is a rational 0 to this cubic, its numerator is a factor of the constant, and its denominator is a factor of the coefficient of the highest degree polynomial. So this one's relatively easy. We don't have too many possibilities. Factors of the numerator are plus or minus 13 and plus or minus 1.
Okay, that's what I got.
Factors of the denominator are plus or minus 1. Therefore, possible solutions, and remember that's only if there are rational solutions, are either of those 4 solutions.
Okay.
13, negative 13, 1, or negative 1. And the way to figure that out is to substitute or divide synthetically.
Synthetic, we've been doing synthetic division.
That's the best way to do this, is synthetic.
Okay. And don't you put 13 on the outside?
You
right?
put it,
Does that sound right?
Every coefficient goes on top.
Okay.
Okay? What goes in the box is your possible zeros. So
right.
I don't know what a 0 is yet. I don't know if it's 13 or if it's 1. I'm going to do 1 because the math is easier on the number 1 than it is on 13. And it is a trial and error process.
Right.
Okay? So what goes here? Help me do this synthetically.
So you just drop down the 1.
Okay.
And then 1
what goes
1
here?
is 1.
Okay. And then what goes here?
That'd be negative 5 minus 1.
Okay, now hold on. With synthetic division, you're always adding.
Oh, you're adding.
Different than long division. Notice that when you divide by a linear factor in long division, you're always subtracting.
Right, okay. So that would be negative 4.
Okay, here.
Negative 4. And then 17 plus negative 4 would be 13. And then 13 times 1 is 13, and then that equals 0.
0 is the magic remainder. If that's 0, then that is a solution.
Okay.
1 is a solution, which means the linear factor is x minus 1.
Okay.
Okay. What's the other factor? The remaining quadratic that we get when we synthetically divide by 1.
So
what is this quadratic? It's x squared minus 4x plus 13. So that's the other factor. Now we're not done yet. Because it says find all real and imaginary factors.
Right.
Well, we found the one real, but this quadratic does not factor nicely.
Right.
We're going to have to use the quadratic formula on it.
Okay.
So we've got, there's one solution. What are the other 2? What's the general quadratic?
X.
In other words, if I'm trying to solve that quadratic to find the solutions, then I need to plug it into the quadratic formula, and I need to know what the general formula is.
So it'd be x squared.
Hold on. It's minus b plus or minus what? What's the rest of it?
Minus b plus or minus square root of b squared plus 4
minus 4ac all over 2.
Yeah.
Okay. In our quadratic here, what is a, what is b, and what is c?
A is -4.
No.
Oh, it's x squared.
It's the coefficient of x squared.
It's 1.
There you go. Remember, A, B, and C are always numbers. They never have a variable with them.
Right.
Okay, what's B?
-4.
What's C?
13.
Okay. So now, let's plug in this quadratic formula to find the other two solutions for this thing.
Okay.
We were lucky in discovering that our very first try found one solution. We might have had to try 4 different things.
Right.
There's no automatic way to figure it out either. It's all trial and error. Who knew?
Right.
Okay, so what's minus B equal to?
Minus B.
Uh-huh. You got B over here. What's minus B?
It'd be +4.
Okay.
Plus or minus square root of 16. Minus 4. 4 times 13.
Notice what the discriminant is. The discriminant is the number that's inside the radical.
Right.
If it's positive or negative, it makes a huge difference. If it's negative, it means we're going to have 2 imaginary solutions. If it's positive, we're going to have 2 real solutions. And if it's exactly equal to 0, we're only going to have 1 real solution.
Right.
But it would be of multiplicity 2. That would be a double 0. Clearly, we don't have a double 0 here, not on this one.
Mm-hmm.
Let's simplify it, though.
Okay, so it would be 4 plus or minus the square root of -36 over 2. Which equals to 2 plus or minus.
Let's do it one step at a time.
Okay.
4 plus or minus, what's the square root of -36?
That would be, wouldn't it be like 6i?
That's it. In other words, the way to do that is if you take the square root of -36, that's the same as the square root of -1 times the square root of +36.
Yeah.
Right? Because you can always, if 2 numbers are being multiplied together, you can always separate it like this. And that's equal to I. So then the problem becomes very simple. It's 6i. Okay? They're both divided by 2, and now I can simplify it more.
So that'd be x equals 2 plus or minus 3i.
Uh-huh.
And then that's it.
Right. So now we have our 3 solutions. We have x equal 1. What are the other 2?
X equals 1. X equals 2 plus or minus 3i.
No, just that's one solution, and the other solution is 2 minus 3i.
Oh, okay.
In other words, I wanted to make sure you understood what that plus or minus meant. It means you do both. To get 2 solutions, you do the plus as one, you do the minus as the other.
Okay.
So the answer to this is right here. Those 3, you've found the 1 real and the 2 imaginary zeros for number 7.
Okay.
Okay. Number 8 is a little more complicated because we have a coefficient in front of the x cubed term.
Right.
Number 8 has some other quality about it that is very useful. It can be grouped.
Right.
Number 7 could not be grouped. What do you need for it to be groupable? The reason 8 is groupable is because 4 over 12 equals 1 over 3. 1 is the coefficient of the x. So whenever this ratio equals, that means we can group it and we don't have to do all that crazy rational factor theorem. So all we need to do is group it. Group the first two terms together and group the last two terms together.
Okay.
Put parentheses around it. Like that. Now, factor out the greatest common factor from the first set of parentheses.
That would be, do you just add them?
No, what's the greatest common factor from those two terms?
Oh, it'd be x.
No, the greatest. In other words, what's the biggest thing that divides into that and that evenly?
Oh, 3.
How about 3x squared?
Okay.
How about 4x squared?
Yeah.
Leaving what? When I do divide 4x squared into that, what do I get?
X plus 3.
Okay. Notice now what we have.
Right.
It's not real common, but in this case, we can factor out the x plus 3. In other words, you don't have to always factor out monomial terms. That's what you've done for 11 years. That's what we all do for the first 11 years of math, is factor out monomial terms. But in this case, we can factor out a binomial term.
Right. So is that the answer? Or no?
What's left after we factor it out?
There's x plus 3. There's...
Remember that whatever's left has to equal this. If I multiply it back together again.
That'd be 4x.
4x squared. That's this term. Plus 1.
Plus 1.
Yeah. In other words, if I divide this term by x plus 3, I get 4x squared. If I divide this term by x plus 3, I get 1. And when I factor out the x plus 3, that's what I'm doing, is I'm dividing that term by x plus 3, and I'm dividing that term by x plus 3. So that's what has to be left. Notice that if I wanted to put these two back together again, I would multiply the x plus 3 times the 4x squared.
Right.
There. And then I would multiply the x plus 3 times the 1. All there.
Okay, I see it.
Okay? And so this is the results of factoring by grouping. Now, that's not an answer yet. That tells you minus 3 is 1, 0. Well, what about this? What can we do with that?
You can...
We could use the quadratic formula again.
Okay.
In other words, there's one thing that's worth noticing here. This term is always going to be positive.
Okay.
This term, I'm adding a positive number to something that's always going to be positive. Therefore, there can be no x that makes this thing 0.
Right.
I can make this 0 with an x of minus 3.
Right.
But I can't make this 0. What does that mean? It means we have two imaginary solutions again.
Okay.
Now, I could go through the quadratic formula and all of that, but I know you know how to do that already, and there's an easier way to do it. Notice that I'm trying to make 4x squared plus 1 equal to 0. Well, let's just do it algebraically. I'm going to move the 1 to the other side, and the reason I do it that is because there's no x term here.
Right.
Which means I'm going to be able to move the 1 to the other side and then solve this thing by taking the square root of both sides.
Right.
Okay, so I basically get x squared equals minus 1/4. See how I get that?
Yeah.
Which means x is equal to what?
That would be x is equal to,
Don't worry about simplifying it. Just how do we solve this? In other words, if I have x squared equals negative 1/4, how do I get x?
you divide,
No. Take the square root of both sides.
right.
Well, when I take the square root of this, I get x. That's what I'm looking for. So I
Okay,
have
so you
to
take
take
the
the
square
square root of this, negative 1/4. That's where I'm going to get my imaginary number. But there's one real key step here that everybody forgets. The plus or minus.
Right.
If I tell you that x squared is equal to 4, then x is equal to plus or minus 2. Notice that minus 2 squared is equal to 4. So both of these solutions are valid. Well, same thing on any equation, regardless of what it's equal to. If you take the square root of both sides, your answer needs to start out with plus or minus.
Right.
Wish I had a song that I could teach people, because I can't get any way for people to memorize that.
Right.
One way to possibly memorize it is that we're looking at a cubic. How many solutions should we have?
3.
Yes. Well, we only got one here,
Uh-huh.
so we better get 2 from this. How do you
Right.
get 2? The plus or minus.
Okay.
Now, what's the square root of negative 1/4?
0.5i.
1/2 I. In other words, 1/2 times 1/2 is 1/4.
Right.
And remember, it's plus or minus.
Right.
So there's our 3 solutions. X equal minus 3, x equal 1/2 I, and x equal minus 1/2 I.
Okay. That makes way more sense now.
Now, I would have gotten those same 2 solutions had I plugged this thing into the quadratic formula.
Right.
And there wouldn't have been any chance of making that mistake, because the quadratic formula has that plus or minus built in.
Uh-huh.
So tell me, what is A, B, and C with that quadratic right there? 4x squared plus 1. What's A, what's B, and what's... In other words, if we were going to plug it into the quadratic formula to solve it, we'd need to know this.
Right. A would be, that would be, where am I? Oh, okay. That would be 4
Good.
x squared.
No,
Or 4, yeah.
Remember, the A, B, and C are always numbers. They're never a variable.
Right.
It's the coefficients. So
And
B
then,
is the coefficient of the x term.
so it would be 1.
No.
Where am I? Oh,
You're right here. You're looking at it right. What's the x term? Where is it? Not there.
doesn't exist. It's not there.
Means B has to be 0.
Okay, and then C would be 1.
Exactly. And C is always the constant. Always. A is always the coefficient of the x squared term. And B is always the coefficient of the x term. So if you don't have an x term, that makes the quadratic formula a little bit easier.
Right.
Now it's minus b, so that's 0, plus or minus the square root of b squared, that's 0, minus 4 times 4 times 1, all over 8. So that's how I get the square root of
-1/4. I think I lost you.
No, you didn't lose me. I'm trying to figure out how come I don't end up with negative 1/4 here. B squared is 0 minus 4 times A times C. So that's this, oh yeah, that's negative 1/4. That's the square root of negative 16, which is 4I, but then it's divided by 8. So it's 1/2 I, which was the answer we came up with the other way. But it is plus or minus. In other words, the plus or minus is built in and it's ready-made. So if you use the quadratic formula, it's really the better way because there's no way to make a mistake.
Right.
Whereas if you do it what appeared to be the simpler way, you can always forget that plus or minus.
Okay.
Yikes.
Let's try number 12.
Okay, well 9 presents its problems all by itself.
Okay, let's do 9.
Well, this leads me to believe that you can use the calculator.
Okay.
Both 9 and 10. And 11 and 12.
And how do I do that?
4 of those are calculator problems. This is a little bit weird because 7 we can actually solve without a calculator. We did it using the rational factor theorem. 8 we solved without a calculator because it's groupable. 9, 10, 11, and 12, I can use the rational factor theorem, but it becomes a 20-minute problem.
Right.
So does 10. Notice how much more complicated these are also. This
Right.
says
So how do I use
possible rational factors are factors of 40. Well, gosh, I got 4 and 10, 20 and 2,
Okay.
8 and 5. I'd be here all day. We'd be here all day. So I don't think they really want you to use the rational factor theorem to solve 9.
Okay.
Putting it in your calculator, do you know how to put this quartic in?
Do you just go into y equals and plug it in?
Yeah. Go ahead and do it.
X to the 4th is 2x.
In fact, while you're doing that, I'll put it into Wolfram alpha.
Alright.
My only real question was what you were supposed to do with these.
Yeah.
And I'm quite certain they don't want you to solve this manually. Wouldn't make any sense to give you that many different possible rational factors.
She just wants us to know how to do it by hand. And
Well,
also by
notice the first one, 7, 13 only had 2 factors, so there weren't a whole lot of possibilities. But this, gosh, the numerator is going to have all kinds of factors in it. All right, did you get it in your calculator?
Yeah.
What are the zeros? Go ahead and try to find the zeros.
Hold on, I gotta readjust this.
Right. No, you definitely have to be able to adjust that window so you see all 4 zeros. If it crosses the x-axis 4 times, then you want to be able to see all 4 of those points. You have to be able to see them in order to use trace.
Right.
And sometimes that's a little tricky, figuring out those calculator windows.
So I got negative 4, 0. I got, let's see here.
Yeah, all 4 answers are integers. So you should be able to get all 4 of them.
And then I got negative 1, 0.
Okay. I trust you can get the other 2. We can go on. The other 2 are 2 and 5.
Okay.
Notice that all 4 of those answers are factors of 40,
Right.
which they would have to be. 10. Go ahead and put 10 into your calculator and come up with those.
All
In
right.
fact, these will not all be factors. I suspect these will not all be whole numbers.
Okay.
Because the rational factor theorem says the numerator has to be a factor of 9, but the
Right.
denominator has to be a factor of 4. So there are all kinds of possibilities here. There's probably 12 to 14 different possible solutions.
Mm-hmm.
That's why I think they want you to do it on the calculator.
Yeah, makes sense.
And then you get to number 12, and we'd be dividing all day long on number 12.
Right.
20 different factors of 84, and then 2, plus it's a quintic.
Yeah. Let's see. I got negative 0.9999, so it would be negative 1.
Okay?
Point, or comma 0. And then, let's see.
Now, you're probably getting fractions. Or decimals that are approximations of fractions. It was like you didn't get 1, you got 0.99999.
I got 1.40, or comma 0.
Okay, 1.4, that's 1 2/5, which is 7/5. That doesn't make sense because the numerator has to be a factor of 9, unless 7/5. Well, let me put this into Wolfram Alpha here. Should have been doing that, I guess, while you were doing it. Now, okay, so the roots I got were -1 and 3/2.
3/2?
Uh-huh.
Okay.
And then there must be 2 imaginary roots, because this is a quartic.
Okay.
Well, I don't see the imaginary roots. Ah, you know what this is these are not, there aren't 2 imaginary roots. Look at this graph here. I don't know if you have something similar on your screen or not, but notice how the graph comes down, touches the x-axis, and bounces up. That means it has a multiplicity there. In other words, we don't just have one solution at -1, we have 2 solutions. If there was only one solution at -1, it would continue on through the x-axis and go down below. So if your solutions have odd multiplicity, they go through the axis. If they have even multiplicity, they bounce off. It's called kissing the axis. Well, it kisses it there, and it kisses it at 1.5. So we have only 2 solutions, but each one has multiplicity of 2. It's a double 0. We have a double 0 at -1. We have a double 0 at 3/2.
Okay.
Furthermore, notice that the 3/2 solution is rational. Rational because I can write it as a fraction. And its numerator is a factor of 9, and its denominator is a factor of 4. That's why when you got 1.4, I was a little suspicious, because 1.4 sounds like 1 2/5, which sounds like 7/5. 7 is not a factor of 9. So I didn't see how 1.4 could be a solution.
Okay.
Okay, it might have said 1.4999 or or something.
Yeah, I think it did.
That's how you would get 1.5. And again, your calculator is not giving you the exact. It's giving you a fraction. It's giving a decimal that once you round it off, you get the exact.
Right, so it'd be -1 and then
0.5, negative, or whatever it was.
1.5?
I think it was positive 1.5. Yeah, positive 1.5. It's -1 and positive 1.5. But in terms of answering the question, it says be sure to identify any double zeros. So there are 2 double zeros on number 10.
Okay.
And there can be triple zeros or quadruple zeros. There are some, polynomials. In other words, you can have whatever multiplicity you want. You can have a multiplicity of 17.
Right.
All right, number 11. Again, I'm expecting the answer on number 11 to be 1/4 perhaps, or 1/8, or 1/16, because I know the numerator has to be a factor of 1 and the denominator has to be a factor of 16. Now, it could be 1, because that would still qualify, but I'm betting that one of these answers is going to be a fraction.
Right.
And it would have to be that fraction. I'll put it in here while you're doing it in your calculator. Notice none of these middle numbers have anything to do with the zeros. Only the 2 end numbers.
Right. I'm still trying to adjust my graph.
No, that's good though. That's you want to get to where you're good at that.
Is it just a parabola, or does it do something else?
No, it looks kind of like a parabola, but it's more like a U with a hump in the middle. More like a W with a small middle.
Okay.
Cortex, in general, look like this. In other words, y equal x to the 4th would look like a parabola, but a particularly flat parabola.
Okay.
With it's not a parabola. It's more of a U.
Right.
Did you get your zeros yet?
No, I'm still trying to adjust it. It's not really.
Now, let's go through how you're doing that. Do you just
with the zoom button,
or do you go in and try to set the x scale and the y scale?
I just put it into standard,
Okay.
and then zoom in or out.
Okay. That works for you?
Yeah.
Most of the time?
Yeah, most of the time.
It's hard. The better way perhaps to do this is notice that I'm looking at one graph right now that obviously I can't see the whole thing in there.
Right.
I know what cortex look like, and they don't look like just that part of it.
Yeah.
Okay, so if I had to set that scale manually, I would maybe try going from -10 to 10 on the x scale. And the y scale, let's go -20. No, let's go -10 to 10 on the y scale also.
So you said -10 and then 10.
I think that's the default, yeah.
What did you say, y min?
Well, go x -10 to 10 and go y -10 to 10.
All right.
That should show you the zeros. In other words, any place that it might be touching the x-axis.
Yeah. Helps, yeah.
Now, on Wolfram Alpha, they automatically zoom out, and we can see that my approximation wasn't very good. Hold on. Okay. Can you see my page here?
Yeah.
Notice what I really needed to make the y-scale. Well, actually, if I'm trying to figure out the zeros here, I need this zoomed in a lot more. I only need x to go from -3 to 3. And I need y to probably go from 0 to 100. Even that, I'm not sure I'm going to be able to see that bump that's right there. Boy, I'm not pleased with Wolfram Alpha's depiction here either. Wolfram Alpha doesn't show you what's going on here either with this curve.
Right.
It does give you the zeros, though. And there's only one real root at -1/4. Right there.
Yeah, that's what I got.
You got that one?
Yeah.
Okay. Question is what is the multiplicity of that root? Well, notice up here, Wolfram Alpha, where it has 4x plus 1 squared, that's a double root. In other words, whenever the exponent is 2, that means there's 2 roots at -1/4.
What? Hold on, sorry.
That's right.
Yes. Sorry about that.
That's okay. So we have 2 roots at -1/4, and I can also see that there's going to be 2 imaginary roots, because x squared plus 1 can only produce imaginary roots, since that has to be positive. So the imaginary roots, how come you're not showing me those? It's plus or minus I. Oh, that's weird. They always show those. You see why it's plus or minus I?
Yeah, because you take the square root of...
Well, we're trying to solve this. In other words, when it factored it into 4x plus 1 squared times x squared plus 1. So either of these can be 0. Well, if we set that equal to 0, we get -1/4 with multiplicity of 2 because the exponent. If we set that equal to 0, we get x squared equal -1, x equal plus or minus the square root of -1. That's plus or minus I. Now, why did Wolfram Alpha not give me that? They usually do. And
so the 3 solutions would be...
There's 4. It's a quartic.
There's 4.
So there's 3 solutions, one of which has multiplicity 2. In other words, one solution is x equal -1/4, which is a double 0, which means there's only going to be 2 other solutions, and the other 2 are plus I and minus I.
Okay, so it's positive 1/4 as well?
No?
No.
-1/4. See here? Just -1/4, but multiplicity of 2. In other words, 2 times you come up with 1/4. If I look at this alternative forms of this quartic, and I go to solve it, well, that has 2 different solutions. That's 4x plus 1 times 4x plus 1. So if either of those can be 0, then we have 2 solutions, both of them at -1/4.
Okay.
And then we have plus I and minus I as 2 more.
Okay.
So there's 4 solutions, -1/4, -1/4, plus I, and minus I.
Okay.
All right. Want to do the last one?
Do we have time for
We do, just about time. I'll be putting it into Wolfram Alpha while you put it into your calculator. It's a quintic, so it's a little harder. We would expect 5 solutions. Boy,
I only got
what a feature
3.
to not have on your calculator. It's such a tremendous feature verifying that I put it in right.
Right.
Okay. So what'd you get for some zeros?
I'm trying to see it still. It's only like showing like 3 lines.
Okay. Here, take a look at my graph.
Okay.
And then see if that helps you define your x and y axis. What should you define x as? From where to where?
From -4.
You better go a little bit left of 4 because,
-6.
yeah, you want to be able to make sure you can pull that 0 up, whatever that 0 is right there. So I would go from -6 to 7 or 8.
Okay.
And then on the y scale, it looks like, hold on, let me look at my second one. No, that's a bigger scale. I would go y from, I guess, -2,000 to +2,000.
-2,000?
Yeah, to +2,000. In other words, that will allow you to see all of your zeros.
Okay, there we go.
There'll be one there, there'll be another one there, there'll be another one there. So I can see maybe 3 zeros, maybe 4, but once again, on Wolfram Alpha, I can't really see it on the graph, although they will tell them to me. Looks like there are 3 real roots and 2 complex roots. Now they give me the complex roots on this one. It's weird how
I got -3.5 for one.
Right?
And it says 9.1e minus 11. I don't know.
It says 9.1 e to the -11.
Yeah.
Wow, I got a weird answer like that on an Inspire today that didn't make any sense whatsoever. And that's not it anyway. The other 2 zeros are -1 and 6. And then there's 2 imaginary zeros. All 5 of them are listed on my screen. You see my screen? Can you see all 5 zeros?
Yeah. So it'd be, the other 2 would be
-1 and 6.
-1 and what?
6.
Okay.
And then the complex zeros are 1/2 minus square root of 7 over 2i, and then 1/2 plus square root of 7 over 2i. Not over, yeah, that is right. In other words, they have the 1/2 factored out here. You would want to multiply it together.
Okay.
In other words, you should give the answer in A plus BI format.
Okay. Yeah, I just did something funky on my
Okay,
graph.
well, you can read it off my page for your paper. Go ahead and
Right.
copy it off of my page, and then you'll have the answer.
All right.
Say you got it from the calculator.
Yeah.
All right. Anything else?
That's it for tonight.
It's pretty complex stuff, actually. Well,
Yeah.
weird that the fact they combined the manual one with the grouping with the ones you had to use a calculator on without
Right.
any instructions. That was a little weird. But all right, Taryn, are we on next Monday or?
Yes. Monday, well, I have a math test on Monday, so I probably won't have anything to work on.
Okay, you want me to just cancel it or move it?
Are you free again next Thursday?
Uh-huh. At what time? 6:30? Yeah.
Yeah, does 6:30 work?
I'll move it to 6:30 next Thursday.
All right, perfect. Thank you.
You're welcome. I'll talk to you next
All
Thursday.
right, have a good night.
You too. Bye-bye.
Bye-bye.